At the western coast of the United States, near the city of San Francisco, lies a narrow and dangerous stretch of water known as the Golden Gate Strait. This strait connects the vast Pacific Ocean to the waters of San Francisco Bay, separating the busy city of San Francisco from the northern lands of Marin County. Today, millions of people cross this water easily, but in the early 1900s, traveling between these areas was slow, difficult, and sometimes dangerous. There was no bridge connecting the two sides. People had only one way to travel: ferries and boats. Every day, thousands of workers, travelers, and goods depended on ferry services to cross the strait. But the Golden Gate Strait was not an easy place to travel. The water here was extremely deep. Strong ocean currents flowed rapidly through the narrow passage. Heavy fog often covered the area, reducing visibility. Powerful winds from the Pacific Ocean created rough conditions. During storms, ferry services were delayed or stopped completely. This caused major problems for transportation, business, and emergency travel. As the population of San Francisco continued to grow, the need for a faster and safer connection became urgent. City leaders realized that building a bridge across this dangerous strait could transform transportation forever. But many experts believed this idea was impossible. The location itself seemed too dangerous. The water was too deep, the winds were too strong, and the distance across the strait was extremely wide. Yet one engineer believed the impossible could be achieved. His name was Joseph Strauss. Joseph Strauss strongly believed that a bridge could be built across the Golden Gate Strait. For years, he worked on plans, studied the conditions, and convinced officials that the project could succeed. He gathered a team of skilled engineers and designers. Together, they began solving one of the biggest challenges: what type of bridge could survive in such extreme conditions? Why other bridge types could not work? Before deciding on the final design, engineers studied several different types of bridges. The first option was a beam bridge. Beam bridges are simple structures supported by many pillars placed in the water. But this design required building dozens of pillars deep inside the ocean. That was nearly impossible. The Golden Gate Strait was extremely deep, in some places over 100 meters. The strong currents made underwater construction very dangerous. Building so many pillars in deep, fast-moving water would take too much time and cost enormous amounts of money. So the beam bridge design was rejected. Next, engineers studied the arch bridge. Arch bridges are strong and use curved shapes to support heavy loads. But arch bridges require very strong supports, often placed in the middle of the span. At the Golden Gate Strait, the distance between the shores was very wide. Constructing massive arch supports in deep water with strong currents was extremely risky. The size of the arch required would also make the structure unstable in strong winds. So the arch bridge design was rejected. Then engineers considered the cantilever bridge. Cantilever bridges extend outward from both sides until they meet in the middle. This design had been successful in other locations, but the Golden Gate Strait required an extremely long span. The weight of such a long cantilever structure would create huge stress. Also, strong winds in the region could create dangerous vibrations. This made the cantilever bridge unsafe, so this design was also rejected. Why suspension bridge was chosen? After rejecting other designs, engineers selected the suspension bridge. This design used tall towers and strong steel cables to support the bridge. Instead of placing many pillars in deep water, the suspension bridge required only a few strong supports. Most of the bridge's weight would be carried by giant cables stretched between towers. This made the suspension bridge the safest and most practical solution. With the design finalized, construction of the Golden Gate Bridge officially began in 1933. Building foundations in deep water. The first major challenge was building strong foundations inside deep water. Engineers used massive steel structures called caissons. These giant, watertight boxes were carefully lowered into the ocean. Once placed on the seabed, workers pumped water out from inside the caisson. This created a dry working space underwater. Inside this space, workers drilled into the rocky seabed. After reaching solid rock, they poured huge amounts of concrete. This formed strong foundations capable of supporting enormous towers. These underwater foundations had to resist strong ocean currents and constant pressure. Building the towers, pillars. After the foundations were complete, engineers began building the massive towers. Each tower was built using large steel sections lifted into position by cranes. Workers used hot rivets to connect steel plates. The rivets were heated until glowing red, inserted into holes, and hammered tightly into place. As they cooled, the rivets shrank slightly, creating extremely strong joints. Slowly, the towers grew taller and taller. Eventually, each tower reached a height of more than 220 meters, making them among the tallest structures in the world at that time. Building counterweights, anchor blocks. At both ends of the bridge, engineers constructed massive anchor blocks, also called counterweights. These huge concrete structures were built deep into the ground. Each anchor block weighed tens of thousands of tons. Their job was to hold the suspension cables tightly in place. Suspension cables create enormous pulling force. Without these anchor blocks, the cables would pull loose and the bridge would collapse. These structures acted like giant anchors, holding the entire bridge steady. Spinning the giant cables. Next came one of the most delicate steps, creating the main suspension cables. Instead of using one thick cable, engineers used thousands of thin steel wires. Workers stretched one wire across the towers, then another, then another. This process continued thousands of times. This method was called cable spinning. After placing all the wires, they were compressed together into massive cables. These cables were then tightly wrapped and secured into the anchor blocks. Now the bridge had its main support system: hanging vertical cables. After installing the main cables, workers attached vertical suspension cables. These cables hung down from the main cables at equal distances. Each vertical cable helped support the bridge deck. This ensured that weight was evenly distributed across the structure, building the deck equally from both sides. Now engineers began constructing the bridge deck, the platform vehicles travel on. But building from only one side would create imbalance. So engineers built the deck equally from both sides. Steel sections were added from one side. At the same time, matching sections were added from the opposite side. This balanced method prevented twisting or tilting. Slowly, the two sides moved toward the center. Finally, both sides met perfectly in the middle. This moment marked a major milestone in the construction process. After completing the steel framework, engineers began building the roadway. Steel beams were placed across the deck to create a strong base. Layers of metal and concrete were then added to form the road surface. Special expansion joints were installed. These joints allowed the bridge to expand and contract due to temperature changes. Finally, the bridge was painted in its famous bright orange color. This color improved visibility in heavy fog and protected the steel from rust. Materials used. Constructing the bridge required enormous quantities of materials. More than 83,000 tons of steel, hundreds of thousands of rivets, thousands of kilometers of steel wire. Thousands of workers risked their lives to build the structure. Construction continued for nearly 4 years. Building such a massive structure required huge financial investment. When construction began in 1933, the total cost was about $35 million. At that time, this was an extremely large amount of money. If converted into today's value, this cost would be approximately $750 to $800 million today. And if the same bridge were built today using modern technology and safety systems, the total cost could exceed $1.5 to $2 billion. Despite the challenges, the project was completed under budget, which was rare for projects of this size. Final completion. After years of dangerous and complex work, the impossible became reality. In 1937, the Golden Gate Bridge officially opened to the public. At that time, it became the longest suspension bridge in the world, stretching approximately 2.7 kilometers across the Golden Gate Strait. The bridge permanently connected San Francisco with Marin County. Travel that once took hours by ferry could now be completed in minutes. The region grew rapidly as transportation became easier. The Golden Gate Bridge is more than just a bridge. It is a symbol of engineering courage. Every part of its construction required precision, building foundations deep underwater, constructing towering steel pillars, creating massive counterweights, spinning thousands of steel cables, balancing the deck from both sides, and finally building a roadway strong enough to carry millions of vehicles. What once seemed impossible became one of the greatest engineering achievements in history. And today, the Golden Gate Bridge stands as proof that with science, planning, and determination, humans can turn even the most dangerous locations into pathways of progress. If you enjoyed this journey through one of history's greatest engineering achievements, please hit the like button, subscribe to the channel, and turn on notifications so you never miss future videos. Thanks.